Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, zigzag tree traversal. Okay, so we'll be given a binary tree. Okay, and what we have to do is we want to print the elements or written the elements in zigzag traversal. For example, so we'll start from root, right? It will be from left to right. So this is the result, right? So we are going to add this, right? And then for the next level, it is going to be right to left, 3, 2. Then for the next level again, it is going to be left to right, 4, 5, 6, 7. Okay, so this is what we want to do. Okay. So alternatively, what we want to do is we want to traverse elements in left to right and right to left. Okay. Order. Okay. And this is nothing but this is level order traverse only, but with slight modification that we have to go in zigzag fashion. Okay. In zigzag fashion. So now, how can we solve this problem? Okay. How can we solve this problem? So what we can do is we can have two stacks. Okay. We can have two stacks. For example, yeah. So one would be current level stack and another would be next level stack. Next level. Okay. So another thing is we are going to have this variable left to right, which will keep track whether we want to move from left to right, we want to traverse elements from left to right or from right to left. Okay. This variable is for that. Now what we're going to do, we are going to ingest this root first into the current level. Okay. First into the current level. This node we have ingested. And now what we're going to do is we are going to run until till this current level is not empty. Okay. So we run this and then what we're going to do, we are going to, for example, this is the result, right? So we are going to pop this element out, pop this element out. Okay. Now we will check whether we want to ingest the left element first, or the right element first. So we are going to use this, right? If it is true, left to right is true, then we are going to ingest the left child first of this popped out node, okay, and then right child later on. Okay, if this left to right is true, then we are going to ingest the left child and followed by right child. Okay, so in the next level, for example, what we did, we now ingest 2 the left child followed by the right child 3. Okay, in the next level. Okay, so now we have done ingesting the children nodes, right? The children nodes we are done ingesting in the next level. Now what we're going to do is we are going to check if current level is empty or not. Yes, it is empty because there's no element now. So we are just going to swap, right? The stacks. For example, so current level will now point to this stack. Okay, and next level will point to this stack. And one more thing we're going to do, we are going to toggle this, right? Now we'll make it false. Okay. Okay. Now current level is not empty. So what we're going to do, we are going to pop this element out, right? We're going to pop this element out. We are going to add in the result, the data result, right? And then we are going to check what is left to right. It is false. So what we're going to do, we are going to, right? We are going to ingest. We are going to ingest. If it is false, left to right is false. So we are going to ingest the right child first into the next level. Okay. So what is the right child of 3? It is 7. So we're going to ingest in 7. So next level is pointing, right? Next level is pointing to this stack. So we are ingesting in next level, right? Then we are going to ingest the left child as well, right? Of 3. So we have ingested left child also, right? We have ingested left child also. Okay. Now we are going to check if current level is empty or not. No, it is not empty. It is still having two, right? 2 as a node, right? So what we're going to do also, yeah. So once we're done ingesting 6 and 7, right? Once we're done ingesting 6 and 7 from, of the parent node 3, okay, then we are going to check if the current level is empty. No, it is not empty. It is still having 2. So we are going to now pop out 2 from current level. Okay. We're going to add the data to. Now we are again going to check if left to right is false or not. Yes, it is still false. So we are still, if it is false, then we are going to ingest the right child of 2 into next level, 5, and then the left child of 2, 4, in this way. Okay. Now current level is empty. Current level is empty. So we are going to do what? We are going to simply swap. So now next level will point to this. Next level will point to this, and current level will point to this stack. Okay, will point to this stack. Okay, and we'll also toggle this left to right to true. Now what we're going to do, we're going to pop this out, right? We're going to pop this out. We ingest the data in the resultant array or list, whatever that is, right? And then we are going to check if the 4 has left child or right child. No, it does not have. So we are not going to ingest anything, definitely. Then we are going to pop this out element, right? We're going to add in the result. We check that, okay, no left child, right child. We won't do anything. Then we pop this out 6, right? 6, again, it does not have any left and right child. And then followed by 7, right? Followed by 7. So in this way, we get our zigzag traversal. Okay. Okay. I hope you have got the intuition, okay, how to solve this problem. Before going to the code, I would request you to subscribe to my channel if you've got the intuition. And after writing the code, I think you will understand the solution. Okay. So first I'll be showing the Java code. Okay. And followed by C++ code. Okay. So let's take two stacks quickly. Node, right? Current level equal to new stack. and then another is next level. Next level. Now what are we going to do? Current level we are going to add the root node, right? We are also going to have a toggle left to right. Okay, left to right, which will be true. Now what we are going to do? We are going to run till this current level is not empty, right? Okay. Now what we do? We pop out. We pop out the top element from current level, right? So when we had, for example, ingested one, right? This was pointing current level. So yes, so we popped out this one, right? Now what we are checking? Here we are checking, first of all, if temp should not be null. So what is temp? Temp is one, this node, right? The popped out node, the popped out node. So what we are going to check? If left to right, if it is true, right? Left to right, if it is true, then ingest the left child. Temp dot left is not equal to null. Ingest the into next level stack. Add temp dot left, right? So what we are doing? We are checking the toggle. If it is true, then add. For example, right? So this is 1. So what we are doing in next level, we are adding the left child of 1, right? The left child of 1, that is 2 we are adding, followed by the right child, 3. Okay. So now what are you going to do? The toggle button is true. So we are going to, okay. So why we are adding 2, 3? The left child first when the toggle button is true. We want to do the traversal from right to left. Okay. But what we are doing, if it is true, left to right is true, right? So we are adding the left child first and the right child because this is a stack, right? When we pop out, so it is going to be the right child first only. So it is going to be right to left traverse only, right? It is a stack. Okay. So we added, right? Now what we're going to do, if it is false, if the left to right is false, then we want to add how? First the right child and then the left child, right? Into the next level, right? We did this. Now what we want to check? If current level is empty, if current level is empty, if current level is empty, now it will be empty, right? So it does not have any element. It does not have any element. So what we're going to do, we are going to swap, right? So stack node temp1 equal to current level. Current level equal to next level. And then next level equal to temp1, right? We are swapping this. Also we'll toggle, right? So now it was left to right was true, right? So we're going to make it false. We are going to make it false, right? So L2R, how it is L2R equal to L, right? So this will make false if it is true and true if it is false. Okay. So now this is done. And also what we want to do, one thing, the important thing, we want to have this resultant list as well, right? The resultant list, right? So what if temp is null, then we can write here, right? Popped out node you want to add. You want to, whatever popped out, you want to add in data, right? So let me now, yes, now return, let me return this resultant list. Okay. Taking time. Time. It gave me some compiler error. Let me rerun again. Okay. Oh, there has been some output difference. Oh, it should have been right. Right. And right here as well. My bad. Okay. Let me submit it. Okay, it is accepted. Now let me quickly. Okay, so this was Java code. Now let me show the C++ code. Before that, I would request you to subscribe to my channel. So yes, so here we are having stack, right? Current level and next level. And then we are having this resultant vector. Okay. what we're doing is we are pushing the root into current level. Okay, and then we are having this toggle. Then if we are checking, right here, what we're doing, we are popping it out, and then we are checking if temp is not null, and we are adding the this temp.data into resultant array vector. Okay, if toggle is true, then we are going to push the left child followed by the right child into next level stack. Else right child followed by left child, right, into the next level stack. And then we are going to check if current level is empty, toggle the this right this flag, and then swap, right, and simply return the result. Okay, so this is a solution. Okay, I hope you have got the solution. Please subscribe to my channel and like the video. Have a happy, healthy, and a great day. Thank you so much.